Hi, I'm Steven with AlbertaUrbanGarden.ca. On today's episode, we're going to go through different grow light technologies and really showcase what they're all about. And then at the end, I'm going to make my selection on how I plan to grow this winter. There are four classes of bulbs that produce visible light: incandescent, CFL, high pressure sodium, and LED. For incandescent, we're really not going to spend a whole lot of time on them for a couple of reasons. They're by far the least efficient of the four options, and they don't usually produce wavelengths that are appropriate for plant growth. We're going to go into CFL, high pressure sodium, and LED light technology because they can all achieve great growth results. So before we get into the technologies, let's quickly chat about what we need. So plants produce energy through a process called photosynthesis. It's where they capture different wavelengths of light and convert that into organic energy. They do that through the use of chlorophyll A and chlorophyll B units within their cell. Now, chlorophyll A and B absorb two different light spectra. They absorb the red light spectra and the blue light spectra. Now, you're asking why don't plants absorb all of the spectra? Well, photosynthesis developed in the ocean. What happens to those higher energy spectra as it hits water? Well, it gets absorbed. And for about 1 billion years, that was the only option available. As blue-green algae, that's where they hang out. So what does this mean for your plants? Well, the blue spectra is between 425 and 450, and the red spectra is between 600 and 700 nanometers. If you're to just give your plants those spectra, they would not know the difference. You could eliminate everything else, and your plants will grow absolutely perfectly. So now, let's talk about the different lighting technologies, and at the end, I'll let you know which one I've selected to use to grow in my house. Let's start off with CFL bulbs. Originally invented in the 1890s, the technology really took off in the 1970s when mass production began to allow them to become economically viable. They consume 1/3 to 1/5 of the energy of traditional incandescent bulbs and have a lifespan 8 to 15 times longer. CFL have an energy efficiency of about 7 to 10%. In some cases, it was reported as high as 15%. Most CFL bulbs emit a wavelength with spikes in both blue and red light spectrums, which combine to make the white light that you see. The further from the plant you have the CFL bulb, the less usable energy is hitting the plant, hence decreasing their efficiency. Of benefit, most CFL bulbs do not emit significant volumes of heat, allowing you to have the plant in close proximity to the bulb to maximize efficiency. CFL bulbs are commercially available at big box stores and are the cheapest on initial investment of the lights we're going to speak about today. High pressure sodium lights were invented in the mid-1950s. In terms of use for growing vegetables, they are more flexible in producing higher volumes of wavelengths the plants can use. As high-pressure sodium lights have higher energy output, you do not need to have your plants as in close of proximity as you do with CFL. Of special note, there are low-pressure options, however, they are not suitable for growth as they only produce low-energy yellow wavelengths and not the red and blue that your plants require. High pressure sodium do have some characteristics that are typically not ideal for an indoor growing situation. Typically, they emit heat on a level enough to require, in most cases, specialized venting to prevent overheating of the fixture and the room. As you would assume, with heat loss and higher energy output of these lights, energy efficiency drops in comparison to other grow light systems. The cost investment is generally higher than CFL bulbs and typically has a shorter lifespan as well. Light-emitting diodes, or LED. This is the third category of lights we're going to talk about, and they work well for growing plants. Initially invented in the early 1900s, the visible light spectrum and hence wavelengths appropriate for growth were only developed in the 21st century and are fast becoming the light of choice for commercial growers. LED lights are by far the most efficient of the three. In comparison to CFL, with maximum energy efficiency of 10%, LED can typically achieve 21% efficiency, with the recent development of an LED fixture by Philips has a reported 67% efficiency. The lifespan of LED in comparison to CFL is 6 to 7 times greater and has nearly zero heat produced while running. LED do not need to be in close proximity to the plants they are growing, as the wavelengths not only are much more targeted to the exact wavelengths plants need, but they're much more efficient and do not lose as much as they travel. LED, unlike CFL and high pressure sodium, are able to emit exact wavelengths of light that target photosynthesis, allowing them to specialize in plant growth. Often, you will see lights emitting a purple light, which is the combination of both the blue and red spectrums that chlorophyll A and B require for growth. Although perfect for plants, you have to be careful when working around LEDs, as the light they are emitting can be beneficial to plants but harmful to your eyes. It is recommended to wear protective glasses while the lights are on. One drawback for the home gardener is the initial investment required to purchase the lights. The initial investment tends to be much more expensive. Generally, in a commercial growing operation, the savings in power over alternate technologies usually pays off the initial investment. Although available in big box stores for household lighting, these LEDs are typically emitting the wrong wavelengths and not quite optimized for plant growth. This decreases any gains in efficiency realized by your plants. My general rule of thumb to use when researching or purchasing grow lights is that you want to get the correct wavelengths measured in Kelvin and higher watt bulbs that emit more light for your plants. It is important to have the light that emits the wavelengths in the blue and red spectrum the plants use. Watts are defined by the amount of energy required to operate the lights. Kelvin, as a unit of measurement, describes the spectrum of light being emitted. Kelvin ratings of 6500 and 2100 hit the blue and red spectrums respectively. This is handy when selecting the right light with the highest wattage possible. Often, I'll mix Kelvin ratings of 6500 and 2100 to ensure I have sufficient light for photosynthesis. Lumens are not the best indicator when purchasing lights for the purpose of growth. Lumens are measuring the amount of visible light hitting a square area. Visible light to humans is only a sliver of the spectrum and does not hit the blue and red spectrums plants need. I choose to grow with CFL bulbs. You can find excellent ones in hardware stores with the proper wavelengths for growth. I mean, we just picked these ones up the other day at a big hardware store. This also means that you don't need to go to a specialty lighting shop, nor order online. Most places have easy access to hardware stores that will sell things that will let you grow quite nicely. The other thing is the fixtures. They're quite a bit cheaper. I mean, this entire setup behind us costs less than $50, and I've been growing with it for a number of years. It also allows you with individual light setups to only turn on what you need. This optimizes the power consumption and really does make it a lot easier to just use what you need when you need it instead of having a large ballast. Further to the optimization of power usage, because you have smaller watt bulbs and smaller fixtures, you're able to consume less power as you're going. Now yes, some of these technologies such as LED is quite a bit more efficient per watt, but they come in large fixtures and you really can't select in most cases to turn one or two of the little areas off. They all turn on or they all turn off. With CFL fixtures, you just unplug one. The rest will continue to work. The addition there is in comparison to high pressure sodium, these don't put off a ton of heat. So you can have this bulb quite a bit closer to the plant. It does need for CFL to be closer to the plant, but you don't have to worry about it radiating heat. What this also means, and as you scale up your growing operation, you don't need to worry about getting rid of that excess heat in your home because the CFL simply don't produce it. You're able to add as many light fixtures as you want and not really need to worry about cooking your plants. Another added benefit of CFL bulbs is seedlings. Some of the larger, higher energy systems out there, they really have a hard time with seedlings because they're producing such a great amount of energy. Those seedlings really don't need it, and sometimes they can actually harm them. So one of the drawbacks here now is if you like a good 1.5 pound tomato, and that's your favorite tomato, and you want to grow that inside, CFLs just don't have the energy output that can be converted into photosynthetic energy to do that. Smaller bodied or medium bodied tomatoes and peppers, absolutely no problem. I've grown them under these lights here, not optimized for anything, without a problem. You do take a little bit less yield overall in comparison to their outdoor counterparts, but you can still get tomatoes and peppers inside, but those big honking ones, you're just not going to be able to accommodate. So if you're just looking for some low energy plants over the winter, a little bit of a project or seed starting, CFLs are definitely the way to go in my opinion. If you want to create your favorite tomato or grow some citrus indoors, you probably want to go with one of the higher output lighting technologies so that you can get enough energy to do that. Over this series of videos, we're going to go through the basics of growing indoors. Thank you for spending time with me today. I appreciate it very much, and I hope you have a fantastic day.